Everyone. So welcome to day 10 of 30-day lead code challenge. I'm still one day behind. Um, but yeah, let's keep going without wasting any time. So today's question is like you need to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So push is like so I guess everyone knows stack, right? So basically we need to implement a class of stack where we have something like this. We push to it. So this will be a push operation. Like let's say according to the example, we push -2. So -2 comes here. Then we push 0. So we have 0 here, and then we push -3. So we have -3 here. Okay, and then we need to get minimum because right now minimum till here is 3, so we get 3, we pop, and then we pop out means we remove this element, so we have only two elements in the stack. And then we need to find a top, so top is for 0 right now, and minimum is obviously -2. So how do we implement a stack class that supports push, pop, top, and retrieving the minimum element in constant time? So constant time means O of 1 operation, right? um, so here is what comes to my mind. We can use an array in C++ as vector. So initially it's an empty list, so int count right now is 0, right? When I push the element to vector, so I have this element -2 here, so I push -2. And because we need to retrieve the minimum element also in constant time, I would basically take another array. So this is my array A, which is the stack, main stack. And then I have array B, which is vector B, and I keep storing the minimum value here, right? Now when I push 0 to the stack, I add 0 to this. My count of element is 2, and then i I compare if 0 is less than -2. No, so I add one more element as -2, right? Just to keep track that okay, till this date my minimum element is -2. Now when I push -3, I add another element -3 here. I make the count as 3, and then I compare -3 is it less than -2, like the current last minimum value. It's not, it is, sorry. So we add -3 as minimum. So now when I do a pop, so obviously before that we have a get min. So when I do a get min, I hit this vector and get this value. So -3 is my current min. Now when I do a pop, I basically pop out from this array. So when I'm popping out, because I keep track of my minimum elements in a different array and the count is same, I pop out this element as well. So now when I do a top, obviously the top would be 0, but when I do a get min will fetch from this vector and give me -2. So in short, I'm trying to use extra space in order to get O of 1 time complexity, which is constant time complexity, right? I'm just using an extra array. So we can see the implementation. We can get on to the implementation. um, so I will take some variables as my member variables. Okay, I initialize it to clean them, so it's empty. Cool. When the push time comes, I do push the element if just push, because if the count is 0, I don't need to take care, and that will be the minimum element as well, right? If it's not I obviously gonna push to X, and then I check if size one is less than the last element in my min stack. So if the new element is less than the one in my min stack, I basically gonna do push underscore back of X, else I do push underscore back of, so which is the last element of my min stack currently, and then obviously I'm gonna increase the count. I can do that here. Right now during pop I simply do, and I pop from this array vector as well. For top I return count became 1 here when the one, so I do count -1 because the index in the array starts from 0, right? So we need to do that. Then in case of get minimum, let's run and see how does it perform. Okay, we got a compiler. Line 35. Oops, we need to return it. My bad, it was a very silly mistake. What happened to the screen? Okay, yeah, sometimes LeetCode just hangs for you. Okay, so what is wrong here? It's giving me top as -3, so pop oops, my bad, we need to reduce the count as well. But there might be a case where we don't want to go beyond 0, right? And 0, so what should I return? -1. I think that case would come. I think the illegal operation is not the case here. I hope my thinking is right here. It looks right. Okay, so we got an error here. Okay, so when I pop 3 elements, the count will be 3. I'm gonna popping out the count because it returns 2 here. Hmm. Maybe we don't get wrong operation. Let's see. Okay, awesome. So there wasn't any there's not going to be any illegal operation, so we don't need to worry about the corner case checks. But I hope the approach is clear how I achieved this in constant time. I just took an extra array, and every time and I get a push operation, I check um, the last element of the stack with the one in the minimum stack, and then I make a push, either push the new element or push the old previous same element there. So basically, in order to keep consistency, I pop out the element from min stack along with my stack, so the consistency maintains, and that's how we achieve constant time. Hope you guys like this video. If so, please subscribe to my channel and don't forget to like it. Thanks everyone.